Okay, so in this one, we're asked to evaluate the double integral. The integrand is e to the y divided by x dA, and r is given to you. Basically, the limits of integration for both y and x are given to you. So really, you don't have to draw anything here. You do have to realize that you have to go with the order. You have no choice here, dy dx, because you can't have like that. So the 0 is a limit of integration, and the x cubed is a limit of integration. Y lies between those in our region R, right? That's what this notation is saying. R is a set of all x, y, all points x, y, such that y is between 0 and x cubed, and x is between 1 and 2. And you can't have a variable limit of integration like x cubed as an upper limit of integration on the outside integral. So you have no choice. You have to set it up in this format. So this integral here is going to be equal to the double integral. Okay, e to the y divided by x doesn't change. It's got to be dy dx, which means the inner limits of integration have to be the limits on the y in terms of x. So 0 to x cubed, and then x runs from 1 to 2. Does that make sense? And this is this is pretty much the only time you shouldn't draw it, because you're essentially given the limits of integration. All right. So if we integrate with respect to y, so looking at the inner integral here, can't separate these things when the limits of integration aren't all constant. So just keep the notation and integrate the inner guy first. So what's the antiderivative of e to the y divided by x with respect to y? Well, start with just e to the same exponent. But then you have to take into account that you're multiplying y times the constant 1 over x with respect to y. 1 over x is a constant, right? So what's going to go on the outside here? Just x. So how do you remember that? I'll show you the trick. If you integrate e to the a times x, or where a is a constant, or cosine of a times x, where a is a constant, or pick your favorite transcendental function, integral of sine of a times x. You could use u substitution and let u be the input in this, the inner function in this case a times x, right? But there's an easier way. Just remember, you're going to integrate you're going to take the usual antiderivative, and then to reverse the chain rule, you have to multiply by 1 over whatever this constant is. Don't believe me? Take the derivative. Show that you get the original integrand back again using the regular chain rule, and you will. Because you differentiate e to the a times x, you get e to the a times x times a. That times a cancels with that guy, and you get back what you started with. So that trick works, and you don't, it's something that comes up so often, it's just, you want to know it. And so what happens when you take, when the a is 1 over x to begin with, or 1 over, I used x over here just as a generic example, but here your a, the thing you're multiplying times the variable of integration is 1 over x, so you take 1 over x, right, out front, and that's just x. Does everybody see that trick? Definitely worth knowing. It's a big time saver. Now, you still have the outer integral, but you're evaluating this antiderivative on the inside. Oh, wait, do I need to include the x? It's y goes from 0 to x cubed, right? So we could actually keep that x on the outside of the evaluation brackets and go 0 to x cubed here. Does everybody see that? Everybody with me? All right. So, this is y. It's really important. Remember, this is y equals 0 to y equals x cubed. So when applying the fundamental theorem, you're going to be plugging in for what? Y, not x. Okay. So if we do that, we get the integral from 1 to 2. X stays on the outside. And then we get, when we plug in x cubed, we get e to the x cubed over x. What's that? E to the x squared. When we plug in y equals 0, so minus, when we plug in y equals 0, what's the exponent become? 0. What's e to the 0? 1. So it'd be really easy to forget, there is something there, right? So we get that. Everybody with me? All right. What would be a logical next step to take on the evaluating this thing? Distribute. Okay, so let me go. Let me condense a little bit, save some room. So what do we get? Integral 1 to 2, distribute what? What do we get? X e to the x squared minus x dx. All right. If it makes you feel comfortable, you could split up the integral, although you really don't have to. What you guys all know how to integrate x or minus x, however you think of it. What technique do you use to integrate x times e to the x squared? U sub. So if it makes you feel comfortable, you could split it up into a difference of two integrals. You don't really have to, but I'll do it because it might look a little better. Integral from 1 to 2, x e to the x squared dx, and then minus integral 1 to 2 of just x dx. Okay, now this is one of those I heavily recommend you don't actually make the substitution. Just kind of write it down as scratch work. What's u going to be? Just x squared and then du? 2x, don't forget the dx, right? So we have x dx, what do we need? A 2, and then, we can't just multiply by 2, it changes it. So what do you multiply by on the outside? 1/2. So just so you don't have to rewrite it, but just so you really see it, if you rewrite this first integral, it becomes e to the x squared, that's e to the u, right? And then 2x dx, if you rearrange that multiplication inside, that's du. So this guy is your perfect du. This guy is e to the u. So what do you get when you take the antiderivative? Just e to the x squared with the 1/2 out in front still, right? Everybody see that? I'm going to do this one in a minute, but I'm going to finish up this integral first. Does everybody see that then? The 2x dx has fulfilled its purpose, right? It is du. Okay, so what do we get when we plug in the upper limit? 2. E to the 4th minus e to the 1, or just e. So times 1/2 on the outside. Yeah? Okay, and then I think we finished off that first integral. What does this integral become? So 1/2 x squared, if we pull that constant out front, evaluated from 1 to 2, or minus 1/2, what do we get? 4 minus 1 when we plug in the upper and lower limits. Everybody agree with that? So what is that? Just 3, so minus 3/2. Of course, it's not. I probably didn't write it that way. Maybe I multiply it. Maybe I factored out the 1/2 from everything. I don't know. And then that seems like a neat way to do it. So if we factored out the 1/2 from everything and dropped these brackets in front, what would it be? Minus just 3, right? I don't know if I wrote it that way or not, but that seems like a nice way to write it. Any questions?